Yeah, today I'm going to look at parametric equations. Last time, many were asking why have I written a chain rule? Yeah, I just wanted to give one hint, but today it is the day of looking at parametric equations, and there we shall be using chain rule. Chain rule is simply dy dx. The camera you bear with me, but it will work. dy dx will equal to, it depends which terms are you using. Like here, I'm going to just do dt dx. I'm using it just in terms of t here, but we shall be using this chain. This is called chain. This is chain rule. Chain rule. Even have product rule, quotient rule. Let us start with this example. Yeah, if y is equal to cos 2t and sine and x is equal to sine t. Yeah, in this case we shall be required to do a second what? A second derivative. A second derivative, someone may ask, let me say it, find dy dx, and this is what I made by second what? Derivative x. Yeah, the challenge, I know in most cases people find challenge here, but today we are going to overcome that challenge in the name of Jesus Christ, of course. Yeah, what are I supposed to do? I'm supposed to first differentiate this in terms of, and differentiate sine in terms of. Yeah, let me start. The light, you bear it with me. Let me start. Yeah, I'm going to start with this one. Y is equal to cos 2t. If you are to differentiate this, you have to first differentiate. Let me call it that. Have to first differentiate this guy here. Yeah, then cos. So if dy, I'm going to differentiate it in terms of t. That simply means it is dy dt. Yeah, some confuse and say dy dx. No, it is dy dt, simply because I'm differentiating it in terms of this one. As I said, first differentiate this. I want to make this more simple. Yeah, though it is pure math. Differentiate this first. It is 2 if you differentiate to t, isn't it? Then differentiate the cos. If you differentiate cos, you get negative sine 2t. But yeah, 2t, isn't it? This one, we are done with this. Then let us also differentiate x is equal to sine t. Same procedure. This is dx over dt. Thank you so much. Dt equal to, if you differentiate sine, you simply get cos t. Thank you so much. Using our chain rule, which says, I stated it earlier here, this chain rule. Are we together? Yeah, is dy dx is equal to dy dt. Because we are dealing with t, you are seeing it here, dt. It changes depending on what you are depending on the question, but the system is the same, the mechanism. Then dt dx. What do we have? If you are keen enough, you can realize that the dy dt, we have it already is here. Then dt, dx, we don't have it, but you have dx dt. Simply means you are going to find the reciprocal of this, which will be reciprocal, everyone knows it. Yeah, from primary. Yeah, as in Uganda. Yeah, let me move on. It will be dt dx. Are you seeing it? Then it will be 1 out of cos t. All together. Now we also have this one, this gentleman here. Come and substitute. But before substituting, if you realize this ident here, from pure math, if you have sine 2t, it is the same as 2 sine t cos t, isn't it? Yeah, this is also important, my friend, to know. Note it down. Yeah, remember, this is scientist Chintu Jonathan. Let us part pure mathematics just in one night. Yeah, in summary. Yeah, this is our formula. Means the dy dx will equal to, we have this one already, which is -2, but we have already found this. Then it will be mod times 2 sine t cos t, isn't it? Times, let me say, but don't think that this is x here. It is just a times. Even this one is a times. In most cases, we use dot here for simplicity. Yeah, without wasting time, dt dx is here, isn't it? Then it will be 1 over cos t. All together, simply means this cos is going to die with that one, leaving us with dy dx equaling to, if you multiply this, what do you get? -4 sine t. Yeah, this was part A. You have found dy dx, but according to the question, they want even the second derivative. Yeah, I know from this part here, it is our part B, they want the secondary derivative. Second derivative, simply to find the second derivative, you simply have to do it in this way. Yeah. Say that you are going to differentiate first this. Of course, we have it. Differentiate dy dx. All together, you're going to differentiate this for the second time. Second derivative. Multiply it with, of course, right now we are in t's. It will be dt dx. And dt dx, you have it as is here also. Yeah, simply this will be equal to, of course, if you differentiate it, let me put it there, because you have it negative sine t times our dt dx is 1 over cos t. Differentiate this. If you differentiate sine, what do you get? I'm waiting for yours. Of course, you have already done it. There, you get what? You get cos. But if you differentiate sine, it is positive. You get cos here. It is positive. But since we have here negative, I'm going to start with -4 cos t. Yeah. All together, I have written a negative because it is here. But if you differentiate sine alone, it is cos. Yeah, cos t times 1 over cos t. This is multiplication. This will die, leaving us with -4. That means for the second derivative here, we shall get 4 as our answer. Thank you so much. I've used the chain rule to come up with all this. Thank you so much. This was the solution. I think now you can solve one. If I did with one, I'm going to do another one. Yeah, I'm going to do another. This is going to be our next question here. It will be y is equal to 3 sine theta minus sine cos theta, and x is equal to cos cubed theta. And this will be our next question up to the second derivative. Yeah.